Good evening, children.
Good evening.
Good
Good
evening.
evening. Good evening.
Good evening, children. Good evening. Yes, please start working this question. Question number 45. Figure 13.105. This one. The question, the information for this figure is given here in question number 45. Please answer this question. Write down the question in your notebook. Draw the figure.
Can you show the question, ma'am?
Yeah, it's here. It's here. This is the figure, and this is the information related to the figure. So I just want to tell you one thing about the figure. It's given that this figure shows the cross section of a railway tunnel. This figure shows the cross section of a railway tunnel. So children, the cross section is the cross. You don't see draw the figure without the line segments OA and OB. See here you can see this figure. You can see the cross section here. They've here shown the center O of this arc. They've shown the center O of this arc, and they've also connected O to A and O to B. But this is for the sake of computing that we have to connect OA and OB. The cross section is only this one. See here, the cross section is this line segment AB and this arc. That's all. This is for the sake of calculation. We make a triangle and all that. So this is not the, see, this alone is not the tunnel, children. This is important to work the answer. What I'm saying is important to work the answer. I'm saying the tunnel is, the cross section of the tunnel is like this. The line segment AB and this major arc, sorry, and this major arc, and this line segment. This is the cross section. It's empty like that. See here, this line segment and this arc is the cross section of the railway tunnel. Now this triangle is shown. This triangle, this is the center of the arc. There's an arc here, and this is the center of the arc. OA is joined, OB is joined. It's given in the figure that this one is a right angle. Angle AOB is a right angle. All this is for calculation purpose. But the cross section is only like this. AB is the line segment, and this is the major arc. That's the cross section. So here the height of the tunnel, The height of the tunnel will be this one. This is the perpendicular height of the tunnel. Where's the tunnel? See here. This is the cross section, right? So the height of the tunnel will be this one from here to here. The length of this line segment. The length of this line segment. The length of this line segment. See here. The length of this line segment is the height of the tunnel. This one is the height of the tunnel. See, this is the maximum point. From there, the perpendicular height. All right. So again, when it is the perimeter of the cross section, children, see, no, because the figure is deceiving in the sense you should not assume this one to be the shaded region, and the perimeter of the cross section is not OA plus. Okay, whatever. It's not like that. The cross section is the cross section. I'll tell you the boundary of the cross section, children. It's the line segment AB and the major arc which you see here. That's the figure. That is the cross section. The cross section is this line segment AB and this major arc. That's all. So the perimeter of the cross, that's how the tunnel will be like. The cross section of the tunnel will be like. Now the perimeter of the cross section is the length of the line segment AB plus the length of the major arc. And then area of the cross section. Is the area of the full thing. The area of the full thing. The area of the full thing is the area of the cross section. This entire thing is the cross section. This entire thing is the cross section. This entire thing is the cross section. So the area of the cross section is this full area. The perimeter of the cross section is AB plus the length of the major arc. And the height of the tunnel is this full height, this one from here, the perpendicular height. This one is the height of the tunnel. So the center, then this OA, OB, angle AOB is 90. All that is to enable us to calculate the values. Yeah, I want you to work this on your own. So I've described the figure. Now it's your turn to start working. Please read the question. If you have any doubt, ask me now. Any doubt regarding the information or the cross section, understanding the cross section? What is the cross section of a cuboid? What is the cross section of a cuboid? When you look at the cuboid, how does one face look like?
Rectangle.
Cross section of yeah. So if you stack up identical rectangles, you get a cuboid. When you arrange identical rectangles, you have many rectangles of the same same size. You stack it up. You stack up many identical rectangles. The solid obtained is a cuboid. The cross section of a cuboid is a rectangle. The cross section of a cylinder is a circle. The cross section of a cylinder is a circle. A right circular cylinder is a circle. Because when you stack up identical circles, congruent circles, you have many circles, many identical circles, you stack them up. What you get is a right circular cylinder. So the cross section of a cylinder is a circle. The cross section of a cuboid is a rectangle. The cross section of a cube is a square. Certain solids do not have a uniform cross section. Now, in our examples, cube has a uniform cross section, which is a square. Cuboid has a uniform cross section, which is a rectangle. A cylinder, a right circular cylinder, has a uniform cross section, which is a circle. So like that cross section, the cross section of this railway tunnel, is like this. is this line segment AB and this major arc. Don't be deceived by the shaded portion, children. That's what I'm trying to say. This entire thing is the cross section. Okay. Yes, how is it going, children?
Yes, ma'am, doing.
Yeah.
Ma'am, I
Okay.
have shared a picture. Could you check it?
Yeah, let me see. Yeah. Even I have to work. I didn't have the time to make the PPT today, so I'm working and sharing the answer. Just try the other subdivisions. Yes, Srinivasan, your answer is right. The height of the tunnel is 2 plus root 2 centimeters. Perfect. So children, the answer to the first part of the question is like this: the height of the tunnel. See here, take a point C here, C and D. Join CD through O. Just to represent the height of the tunnel. Just to represent the height of the tunnel. Do that marking in your book. Take a point C here, and D here. Join CD. Let that represent the perpendicular height of the tunnel. So CD here through O. So now what is CD? CD is the height of the CD represents the height of the tunnel. And CD is equal to, what is CD equal to? OC plus OD. OC plus OD. Now OC we already know is the radius of the circle. OC is a radius. So that's 2. That's given to us in the question. If you mark this as C and mark this as D, join CD through O. Let that represent the perpendicular height of the tunnel. Now OC is 2 because it's a radius. It's given to us. So we only have to find the length of OD. OD. You can use trigonometry. You can use trigonometry to find OD. To find OD, you can use trigonometry. Because this one is 45. This angle is 90 degrees. This will be 45. This will be 45. So OD, this is OD. Connect 45 degrees with OD and the hypotenuse OA, which is 2 meters. This is 45 degrees. Connect 45 degrees with OD and the hypotenuse OA, which is 2 meters. You will find that OD is root 2 meters. So now the height of the tunnel is 2 plus root 2, which is 2. You can leave it like that, 2 plus root 2 meters. So I said let this represent the height of the tunnel. This one represent the height of the tunnel. So the height of the tunnel is OC, which is 2 meters already, plus OD. So you only have to find OD. That's all. You only have to find OD. And how will you find OD? How will you find OD? It's a right triangle. OAD is a right triangle. And how will you find OD from it? You'll have to connect 45 degrees with OD and the hypotenuse OA, which is 2 meters. And that will be root 2. OD will be root 2. So 2 plus root 2 is the height of the tunnel. Yes, find the perimeter. Find the perimeter and the area of the cross section. Please ask me if you don't understand. Somebody tell me, what is that expression to find the perimeter of the cross section? What is the expression? Now we have taken a point C here, right? We have marked the point C here on the arc. Now tell me, how do you find the perimeter of the cross section? Quickly.
Length of the
AB plus RKDB.
line segment AB.
Yeah, line segment AB plus length of arc
AB.
A
ACB.
ACB. We have taken a point C here. ACB. Length of arc ACB. Length of this arc ACB plus BA will give us the perimeter of the cross section. You can find AB. You can use Pythagoras theorem because this is 2 units, 2 meters. OA is 2 meters, OB is 2 meters. So you can find AB using Pythagoras theorem. And then how do you find the length of the arc ACB? How do you find the length of the arc ACB?
Theta by
270 by 360 into pi.
Very good. That's all. 270 by 360. 270 by, somebody said theta, but that's correct. So 270 is the angle because the angle in the major sector, this angle is 360 minus 90, 270. So 270 by 360 into 2 pi r will give us the length of this arc. We know the radius is 2 into 2 pi r will give us the length of this arc. So 270 by 360 into 2 pi r, where r is 2 meters, plus AB, which you can find using Pythagoras theorem. So the length of the arc plus the length of the line segment AB will give us the perimeter of the cross section. Will give us the perimeter of the cross section. What about the area of the cross section, children? How do you find the area of the cross section? What is the cross section made up of? What are the two plane figures the cross section is made up of?
Major sector and
Major sector and right angle triangle.
Yeah, major sector and a right angle triangle. The entire thing I told you is the cross section, children. This has been marked for the sake of computing. Otherwise, if you have to draw, supposing you have to draw the cross section of a tunnel, say, you need not show all this. You will only draw this line segment AB and this major arc. That's all. You will draw this line segment AB and this major arc. That's all. That's the cross section of the tunnel. Like you draw the back of an elephant. When we were young, that's how you draw the back of an elephant, right? So this is like the back of an elephant. That's it. Yeah. So why this triangle, why this is shown is for calculation purpose to show the radius. And don't get deceived by the shaded region here, children. Don't think only the shaded region is the cross section. Do not get confused with the shaded region here. I'm repeating, the entire thing is the cross section. The whole thing is the cross section. Okay. Now the area of the cross section, as you all rightly mentioned, is the area of the major sector plus the area of the triangle. The area of the triangle is easy to compute, half base into height. Because OA, you can take OA as the base and OB as the height because they are at right angles to each other. Half OA into OB. Half OA into OB will give you the area of the triangle. Find the area of the major sector, add both to find the area of the tunnel, area of the cross section of the tunnel. You can leave your answer in root 2. You can leave your answer in surds, children. Don't use a decimal value. Just leave it in surds. Yes, I've got the answer from Srinivasan, Shakti and Shriya. Yes, you should have finished by now. What's the length of the line segment AB, children? How much is
Ma'am.
AB?
It's 2 root 2, ma'am.
2 root 2. AB is 2 root 2 meters. Correct. And what about the length of the major arc? Tell me in terms of pi. Tell me in terms of pi.
3 pi, ma'am.
6 pi, ma'am.
Is it 3 pi? In terms of pi, is it 3 pi?
Yes, ma'am.
Yeah, so it
Yes,
is 270 by 270 by 360, which is 3 by 4 of 2 pi r. So 2 into pi into 2. So 3 pi. So the length of the major arc, the length of the major arc is 3 pi. This one, the length of the major arc is 3 pi. And this one is 2 root 2. So 3 pi. Children, in the exam, you have to find the values in decimal, children. You'll have to use the value of pi and then the value of root 2. That will be given to you. Root 2 will be given to you. But for now, we leave it like this, 3 pi. 3 pi, the length of the major arc is 3 pi. The length of AB is 2 root 2. So 3 pi plus 2 root 2. Very good. Now the area of the cross section.
Ma'am, it's coming as 80 by 7.
Okay.
3 pi plus 2.
2, ma'am. 3 pi plus root 2, ma'am.
3 pi plus root 2.
3 pi plus 2, ma'am. No, 3 pi plus 2, ma'am. Sorry, ma'am.
Yeah, that's what, 3 pi plus 2. Because the area will be the same again because the radius is 2. The area is 270 by 360 into pi r square, where r is 2. So that is 3 pi. And the area of this triangle, is half base into height, which is 2. So 3 pi plus 2 is the area of the cross section. You need to find the area of this triangle. You need to find the area of the major sector, add both to get the area of the cross section. Yeah, children, do this one. This one, the figure is here. I'll show you the question. It's below here. This is the figure, children. You know how a racetrack looks like. So this is the figure. I'll show you the question. It's right here. It's right below here. It's 11th question. Please try the 11th question. The 11th question, the figure, you can see it on the top of the next page. The inside perimeter of a running track is 400 meters. The length of each of the straight portions is 90 meters and the ends are semicircles. If the track everywhere is 14 meters wide, find the area of the track and the length of the outer running track. Yes, how do we express the inside perimeter? Inside perimeter is 400. How do you express 400? 400 is,
Length of two arcs plus length of the two straight portions.
yeah, so it's 90 plus 90 plus, it's 90.
Pi r plus pi r.
Yeah. So the inside perimeter is this one. We have understood what this figure means, children, earlier. We have seen a similar situation earlier. This is the inside perimeter. This is the inside perimeter. The inside perimeter is made up of two line segments of length 90 meters and two semicircles. See this inner boundary. This inner boundary is made up of two line segments and two semicircles. So 90 plus pi r, small r, is equal to 400. Is equal to 400. Working that, you can find the value of small r. What's the value of small r?
$35 meters.
35. 400 minus 180 is 220. Yeah, R is 35. R is 35. Small r is 35 meters. What's the value of capital R then?
49.
35 plus 14, because the width of the track is given to us. The width is 14. So when the inner radius is 35, the outer radius will be 35. Inner radius 35 plus the width 14. 35 plus 14 will be the value of capital R. The inner radius 35 plus the width 14 will be the value of capital R. Yeah, now you have all the values. Find the area of the track and the length of the outer running track. Somebody from the girls, tell me, how do we find the area of the track? Just tell me the expression in words. What all areas should we add to get the area of the track? Why, children? How do you find the area of the track? What should you add to get the area of the track?
Area of two semicircular rings, ma'am.
Yeah. Plus
Area of the triangle, ma'am. That
Area of rectangle.
area of two rectangles.
rectangle, ma'am.
Rectangles. So this one is a track. The area of the track will be the area of these two rectangles. Area of these two rectangles plus the area of two semicircular rings. So when you put these two rings together, they make one circular ring. This end and this end together, when you put it together, they make one circular ring. So area of two rectangles plus the area of one circular ring will give us the area of the track. What's the length of the rectangle, children? What's the length of the rectangle?
90 meters.
90 meters. What's the breadth of the rectangle? What is the breadth of the rectangle?
17.
It's 14. 14 meters. So length 90, breadth 14. So that will give us the area of the rectangles. What about the what's the formula to find the area of a ring?
Pi into r square minus r square.
Pi capital R square minus small r square. And we know the values of the two r's. Yes. Now you can find the area of the track and tell me, how do we find the length of the outer running track? This length, this outer running track. The length of this outer running track.
Ma'am, 90 plus 90 plus 2 capital R. 2 pi capital R.
Yeah. So 90, the length of this straight edge 90 plus the length of this straight edge 90 plus this big this big, the sum of the two big semicircles, the outer semicircles, the length of this semicircle plus the length of this semicircle, because we need to find the length of the outer edge, which is made up of two line segments, two straight lines, or two line segments, 90, 90. And there is one semicircle here and a similar semicircle here of radius capital R. So 90 plus 90 plus pi capital R plus pi capital R. That is 2 pi R. 180 plus 2 pi R, where R is 35 plus 14, 49. That's it. We'll give you the length of the outer running track. Children, please work. It's important to work. Yes, complete it. Use small r, capital R. All this you're working. Is it over, children?
No, ma'am.
No, ma'am.
Okay, okay. Please complete it here. Yes, children, it's time.
Ma'am, length of outer track is 488.
Yes, ma'am.
488. Are we all getting that?
Yes, ma'am.
Yes, ma'am.
All right.
Ma'am, what is the area of the track?
What's the area of the track, children?
6,216 centimeters.
6,216.
16.
Yeah, here it is. 6216 meters squared and 488 meters. Area of the track is 6216 meters squared and the length of the outer edge is 488 meters. Yes. I have a question in my mind, but I'm not able to find it here. I'm going to share the question on WhatsApp, children. Please find the question on WhatsApp. I've shared a question on WhatsApp, children. Please find the question, start working that. It's question number 8. I've shared a question on WhatsApp. Please find the question, start working that. Write down the question first. So according to the question, a bucket is raised from a well by means of a rope, which is wound round a wheel of diameter 77 centimeters. So the diameter of the pulley is 77 centimeters. Given that the bucket ascends in 1 minute 28 seconds with a uniform speed of 1.1 meters per second, calculate the number of complete revolutions the wheel makes in raising the bucket. It's similar to that, the car wheel and similar question. So you're given the radius of the car wheel, the distance is given, and how many revolutions will the wheel go to cover that particular distance. Similarly here, it's about the wheel, and yeah, I'm not giving you any more clue. Let's see how you can think and work this. We'll discuss the answer though. Please read the question many times. Understand. You should understand what information you should find first. How do you start off? That's important. Think.
Ma'am, 400 revolutions.
Exactly 400 or
Ma'am, 40 revolutions.
Exactly.
okay. I think I got two different answers from you. One said 440, another said 44, correct?
Ma'am,
Ma'am,
40
400.
revolutions, ma'am.
No, ma'am.
What's the
40,
answer?
ma'am.
Can I get the answers again?
Ma'am, 40 revolutions.
40. Okay, one says 40 revolutions. Okay, then any other answer?
400 revolutions.
400. Okay, 400 revolutions.
40.
40. How many of you say 400? Somebody said 400, right?
Ma'am, Srinivasan.
Srinivasan 400. How many of you say 40?
Ma'am, Priya, ma'am.
Priya then?
Bhargavi, ma'am.
Bhargavi. Who else? All right. What was the first step, children? What did you first find?
And distance.
Distance. You found the distance first. How do you find the distance? How do you find distance? Speed into time, right?
Yes,
Okay.
ma'am.
What is speed given there?
1.1.
1.1 meters per second. Okay, speed into time. What's time? What's the time?
88 seconds. 88 seconds.
Why should you convert it to seconds? Why not to minutes?
Distance traveled is speed is in seconds, ma'am.
Speed
Yeah,
is meter per second, ma'am. So
yeah. So because speed is expressed in meter per second. Speed is expressed in meter per second. So you need to convert time to seconds. 1 minute and 28 seconds is 60 plus 28, 88 seconds. Correct. So speed into time. Speed into time. The speed is 1.1 meters per second. So 1.1 into time 88 will give you 96.8 meters. 96.8 meters. You will get the answer in meter because speed is in meter per second. 96.8 meters, which is equal to 968 centimeters. Convert that to centimeters because the length of the radius of the wheel is given in centimeter. So 96.8 meters or 9680 centimeters. Srinivasan, you took one extra zero, is it?
Yes, ma'am, I went wrong in conversion.
Yeah, that's what you would have overlooked the decimal point. Probably you just looked at it as 968 meters.
Yes,
Yeah.
ma'am.
Correct. Okay, so 96.8 meters or 9680 centimeters. Convert meter to centimeter. So this is the distance that is to be traveled by this is the length of the rope. So the distance here is nothing but the length of the rope. Distance here implies the length of the rope. The length of the rope is 9680 centimeters. Now Now the only the rope, this length of the rope has to come up so that you reach the bucket, so that you can pull the bucket out of the well. The distance is 9680 centimeters. Now we know that the circumference, that is the distance. Okay, next let's do this. Let's find the distance covered in one revolution. What is the distance? What is the distance of the rope that is moved in one revolution? 2 pi r. 2 pi r. Find 2 pi r. 2 pi r is the length of the rope that is moved in one revolution. When you find 2 pi r, so 2 into 22 by 7 into r, 77 by 2.
Ma'am, 1540 centimeters.
What is 2 pi r?
It's 154 meter, ma'am. If we convert in centimeter, it's coming 1540.
No, 2 pi r. 2 pi r. 2 into 22 by 7 into r. 77 by 2 is r, right?
And 2.42 meter.
Yeah, 24. No, I'm not getting such a big value. 242. What did you say?
Yes, ma'am. 242 is coming, ma'am.
242. Yeah, 242. 242 meters.
Ma'am, 242
Centimeters.
centimeters.
Centimeters. Sorry.
Yes,
Centimeters. So this is how we go. So the first thing is we found the length of the rope, the distance we found. See, we are given speed and time, children. In the question, we are given speed and time. The speed at which the rope moves, like the speed at which the car moves, the speed at which the rope moves. And then the time factor is given to you. Time is given 1 minute, 28 seconds. So using speed and time, you can find the distance in meter and then convert it to centimeters. Now distance here represents the length of the rope. What is the length of the rope moved in one revolution? What is the length of the rope moved in one revolution? 2 pi r.
Yes.
2 into 22 by 7 into 77 by 2, which works to 242. So if 242 centimeters of rope moves in one revolution, then how many revolutions will the pulley go to pull the length of 9680 centimeter? That is the argument. 242 centimeters in one revolution. 9680 centimeters in how many revolutions? So you'll have to divide 9680 divided by 242, which is 40 revolutions. I want you all to read the question again. I'll just, if I try to explain again without pausing, it might, you might not receive it completely. Let me just pause for some time. I'll give you some time. Read the question. I'll come back with my explanation. I'll repeat the same thing.
Excuse me, ma'am.
Yes.
Answer is coming in something decimal, ma'am. We want to round it up, ma'am.
No. Tell me what you want. Just tell me. Just read your steps. I'll help you.
Ma'am, it's coming 39 point something.
Shakti, you can share your picture on WhatsApp.
Okay.
Shakti, please share your picture on WhatsApp. If you're not getting it, it's exactly 40 revolutions. The answer is exactly 40 revolutions. In case you're not getting it, put your picture on WhatsApp. First, using speed and time, we need to find the distance. Speed is in meter per second. So please convert time to seconds. Then speed into time will give you the distance. You will get the distance in meter because speed is in meter per second. You will get the distance in meter. Convert that to centimeter. That is one thing. Now what does this distance imply here? It's the length of the rope. It's the length of the rope. So what length of the rope moves in one revolution of the pulley? In one revolution of the pulley, what length of the rope moves? 2 pi r, which is 242 centimeters. So 242 centimeters, this length of the rope moves in one revolution, is pulled up in one revolution. 242 centimeters, this length of the rope is pulled up by the pulley in one revolution. So centimeters, if this length of the rope has to come up, how many revolutions? Which is 40 exactly. I haven't got your picture still. Shakti?
I got the correct answer, ma'am. There was a division error.
Okay, okay. No, don't compromise. If you didn't get it, please share the picture. I'll tell you where you've gone wrong. You found your mistake?
Yes, ma'am. I divided wrongly.
Okay, okay. Because it's precisely 40, 40 exactly. Yes. The 51st question, children. Let me see if you remember. 5-1, 51. Work the 51st question. I hope you're all working the 51st question. Yes, what's the area of the three sectors? Can we find the area of the sectors separately? Area of the sector which is grazed by the cow, area of the sector which is grazed by the buffalo, area of the sector which is grazed by the horse. Can we find the area of the sectors separately?
Ma'am, I started with triangle.
Oh, you started with the area of the triangle, huh?
Yes, ma'am.
No, that's okay. But my question is, can we find? Oh, I have to repeat that lengthy question. My question was, can we find the areas of these sectors separately, individually?
Yes, ma'am.
Okay.
Yes, ma'am, we can find it.
Okay, then go ahead. Tell me. I want to know the area of the sector which is grazed by the buffalo. Now you all, some of you said yes. Now I want that answer. I want to know the area of the sector. No, somebody said
Ma'am,
yes.
7.
Somebody said yes. I want to know the area of the sector that's grazed by the buffalo. My question was, can we find the areas of the three sectors separately?
No, ma'am.
Can we find the area that is grazed by the cow, the area that's grazed by the buffalo, the area of the sector grazed by the horse? Can we find that? No. Why? Why?
No, ma'am.
Missing? What is missing?
Because the sector angle.
Yeah, because the sector angle is not known, and you can by no means find the sector angle. Because the sector angles are not known. If you had at least two angles, you can find the third one. If you had, and the scaling triangle, don't think you can drop a perpendicular, show the triangle, the congruent, or some side is bisected. Nothing you can do because it's a scaling triangle. It's not an isosceles triangle. The scaling triangle, 15, 16, 17. So you can by no means, if you know two angles, you can find the third one. Angle sum property. So here you cannot find the sector angles. So when you don't know the sector angles, then how can we find the areas of the sector separately? No, but we can find the collective area. We can find the collective area of the three sectors. Yes, children, I want that answer now from you. What is the area of the three sectors?
Ma'am, 77 meter.
77 meters.
Now, if it's an objective question, children, if it's an objective question, see okay, take this as an objective question. I say that with respect to a similar situation, all right? With respect to a similar situation. So I say that the radius of the sector is say A units. Radius of the sector is A units. Now, what will be the collective area of the three sectors? That's all. That's the question. A similar situation. If the radius of each of the sectors is A units, A small letter A, what is the collective area of the three sectors?
22 by 7 A square, ma'am.
22 by 7 A square. No, I don't know if you're right. Just wait for other answers.
Ma'am, pi A square by 360 into 180 degree.
No, darling, don't. Tell me that fine. After simplifying, tell me. Work it in your book. Tell me after simplifying. I want a small expression as the answer. That's all. So you'll be given some options. You'll be given some 4 options. You should know which one to select.
Half pi A square.
Okay, I'll just keep that answer. Yeah. Somebody said pi A square. Then now you say half pi A square. Yes. Other answers?
Half
Half Half pi a square is the correct answer, or pi by 2 a square. Pi by 2 a square. Because how will you work it? Angle A by 360 into pi a square. Angle A. Area of one sector is angle A by, I'm just calling the triangle as ABC. So angle A by 360 into pi r square plus angle B by 360 into pi r square plus angle C by 360 into pi r square. So what is common? Pi r square by 360 is common. So in bracket you have angle A plus angle B plus angle C. But we know that the sum of the three angles of a triangle is 180. So pi a square by 360 into 180. 180 and 360 simplifies to 1 by 2. And that way we have half pi a square. Half pi a square. The area of one sector is angle A by 360 into pi a square. The area of the second sector, angle B by 360 into pi a square. A is a radius. I told you the radius is A. Then the third sector, angle C by 360 into pi. Instead of pi r square, I'm saying a square because the radius is given to be A. Now, if you see, you have to add all these three, but what is common? Pi a square by 360 is common. So bring it out and then in a bracket you can write angle A plus angle B plus angle C. Because that's what, when you take out pi a square by 360 common, that's what you get in the bracket. But we know that A plus B plus C is 180. So pi a square by 360 into 180, which is half pi a square. What if four animals are tied to the four corners of a quadrilateral? What will be the area of the four sectors? Take the radius as r, children. Take it as r. Radius r. Four animals are tied to the four corners of a quadrangular field. This is a triangular field. Four animals tied to the four corners of a quadrangular field. What's the area of the four sectors? Let's call it. Yeah, pi r square. Pi r square. So if you call it PQRS, if you call the quadrilateral PQRS, so the area of the four sectors, that is the collective area. The total area of the four sectors will be, somebody tell me, no, what will be the area of the four sectors together? How will you find? Angle P by
360 into pi r square
plus
angle B by 360 into pi r
no,
square
I said
plus
PQRS.
plus angle Q by 360 into pi r square plus angle R by 360 into pi r square plus angle S by 360 into pi r square.
What is
Pi
common?
r square by 360. Pi r square minus by 360 is common, ma'am. Into angle P plus angle Q plus angle R plus angle 6.
Yes, very good. Next.
Then pi square by 360 into 360, ma'am. The angle of quadrilateral, sum of the angles of quadrilateral is 360, ma'am.
Very good.
So pi square by 360.
So pi r square by 360 into 360. 360 gets cancelled, so pi r square. So you can remember this. So when three animals are tied to the when three animals are tied to the three corners of a triangular field, the sum of the areas of the three sectors is half pi r square. It's half the area of a full circle, pi r square by 2. But if they are tied to the corners of a quadrangular field, the sum of the four sectors meaning the sectors which the animals can graze, the sum of the areas of the four sectors will be pi r square. Pi r square, area of one circle of radius r. Yeah, now complete this, children. Now find the area of the three sectors. So you cannot find the area of the sectors separately. Total area of the three sectors you can find. You should find the area of the triangle using Heron's formula. Subtract to get the area that cannot be grazed by the three animals. Yes, I want the two answers, area of the field and area of the sectors.
Ma'am, area of the field is 24 root 21, ma'am.
24 root?
21, ma'am.
Okay. All right, what about the sectors, area of the three sectors?
77 meters.
77 meters. Okay, so in the exam, you will be given the value of root 21. Then in that case, you'll have to multiply 24 and the value of root 21. And the difference will give you the area of the three, the difference will give us the area that cannot be graced by the three horses. Okay. Yes, children, this one now, figure 3.100. Example 40. Please work example 40. In case you have not finished the earlier one, please finish that, children. You can share your answer with me. Somebody said 24 root 21. That's correct. That's the area of the triangle, 24 root 21. And the area of the three sectors, 77 meters square. Who can express the idea in words?
Find diameter of semicircle.
No. What I'm expecting is, how do you find the area of the shaded region? How do you find the area of the shaded region? Express that in words. Like area of something plus area of something minus area of something.
Area of triangle plus area of semicircle minus area of quadrant.
What does the area of the triangle and the area of the semicircle give you? What does it give you?
The whole figure.
Area of whole figure, ma'am.
Yeah, the area of the entire figure. The entire thing is like as if you have a triangle. It's like you have, I think this one is in NCRT also, the NCRT textbook. So the whole thing is like you have a triangle. You have a triangle and you have a semicircle with diameter AC. So you bring them together, you put them together like this. Is what the entire figure is. The entire figure is the area of the triangle ABC plus the area of the semicircle with AC as diameter. So from this total area, if you take away, if you cut off the area of the quadrant, see, you just try, so you have the full thing with you. You have the triangle and the semicircle together like this. That's the area of the full piece. From that, you take a scissor and you cut off this piece. You cut the area of, you take away this quadrant. You will be left with the area of the shaded region. So as someone rightly mentioned, area of the triangle, I think it was Srinivasan, plus the area of the semicircle minus the area of the quadrant. Very good. So see, the idea is simple. Meaning, I won't say simple. Okay, you got the idea right. But what is important is to take the values carefully. The values of the radius carefully. That is what is important. Yes. I want you to complete the answer. If you finish this, you may try the 38th question, which you see right on top of the first page. You can try this one. If you finished 40, please try question number 38, which is right on top of the first page. Yes, class, use the emoji, raise your hands. That's great. Very good, children. Very good. Very good, children. Very nice to see you all in the meeting. Yes. Please continue. Good, children. If you finished, please announce the answer. What is the area of the triangle? What's the value of the area of the triangle?
It's 294.
294 meters.
294.
Okay, half base into height, 294. What's the radius of the semicircle? What's the radius of the semicircle?
It's
35 by 2.
Okay, so the diameter is 35 and the radius is 35 by 2. Okay, what's the area of the semicircle?
481.25.
481.25 centimeters square.
Nice. So the area of the triangle is 294 centimeters square. Semicircle, the diameter is AC. So you should find AC using Pythagoras theorem. You must find the length of AC using Pythagoras theorem, which is 35. 35 by 2 is the radius of the semicircle. Because AC, the hypotenuse AC is the diameter. Radius is AC by 2. Okay, so you all said that the area of the semicircle is 481.25. What about the area of the quadrant? What is the radius of the quadrant? Is it 21 or 28?
21, ma'am.
21, ma'am.
No, but I can see 28 also there. How do I know that it's 21 and not 28?
Ma'am, 28 is
Ma'am,
for
because
AB.
20 is the AB whole, ma'am. The whole thing is 28.
Yes, ma'am.
Yeah. So AB is 28. AB, this one from here, AB. AB is, so B is the center of the quadrant. B to this portion is the radius. But BA is 28. BA is beyond the, so see, this is the center. This is the point on the arc. This is the radius from here to here. So BA is not the radius of the quadrant. BC is the radius. You can see B the center and C is a point on the arc. It's a point on the arc. C is a point on the arc. So BC clearly is the radius. It's given as a different thing. It's given there, but you might have a doubt, why not BA? How come BC and BA are the radius, but they have different values? You might have been confused. BC and BA, if they're the radius of the quadrant, they must have the same radius. Why? This is 21, this is 28. So BC is the radius. Excuse me. Okay, let me, 1 second. So BC is the radius. BA is not the radius. It's beyond the radius. Give me a minute, children. So just in case you had that doubt, just in case you felt, BA is equal to BC. No, BC is the radius. It's given here BC is the radius, but BA is beyond the radius. This is the point on the circumference of the arc. So BA is not the radius. Yeah, what's the area of the quadrant?
346.5 centimeters per minute.
693 by 10.
No, I want one uniform answer for the area of the quadrant.
Ma'am, 346.5.
346.5.
346.25.
No, I didn't get it clearly.
346.
ma'am.
I'll find it myself. I don't. I think you all said 346.5.
Yes, ma'am, it's only.
Okay,
Yes, ma'am.
346.5. Okay, now tell me the area of the shaded region.
228.75, ma'am.
It's 294 plus 481.25 minus 346.5, which is 428.75, right?
Yes, ma'am.
428.75. All right. Yes. Who have the 38th one? 38. Just answer the radius for me. Just tell me what is the length of the, sorry, what is the value of small r and capital R? The radius of the incircle and circumcircle. I just want that ratio you can find. What is the value of capital R and small r? We'll work that first.
Small r is A, ma'am.
Small r is A. Very good. Yes.
Ma'am, capital R is root 2A, ma'am.
Very good. How did we find capital R? What did you
Ma'am,
first?
the outer is
Yeah, how
the
did we
diameter
first find? You found AC? Tell me the line segment in this figure which represents the value of capital R, the radius of the circumcircle.
AO, ma'am.
AO or OC.
Yes, ma'am.
AO, OC represents the radius of the circumcircle, because from the center to a point on the circumference, from the center O to the point A or C on the circumference. So OA, OC radius. So how do we find that?
Ma'am, we can take the triangle
Root
ABC. ma'am.
You can take the
We
triangle.
can take the
Triangle ABC, ma'am, and by that we can find the hypotenuse, ma'am.
Correct. You can, so we can take up the right triangle. We can take up, you can use the formula diagonal is given by root 2a. Diagonal of a square is given by the formula root 2a. You can use the formula, or you can take up a right triangle like this ABC or ADC. Use Pythagoras theorem 2a 2a. Find the hypotenuse using Pythagoras theorem. Okay, so the hypotenuse will be 2 root 2a. 2 root 2a, the hypotenuse. AC, that's a diameter. So what's the radius? Half of that. So root 2a.
It's root 2A, ma'am.
Correct. Root 2a. How do we find the value of small r? I'll just call this one as M. Take this as M. Using right triangle AMO, how do we find the in radius OM? Mark this as M. Mark this as M. M. How will we find OM? OM is the in radius. How do we find OM? Okay, so you know it, but I don't know why you're not
angle,
answering. Yeah,
angle OA is right angle.
yeah, OMA is a right angle, yes. Because radius and tangent at the point of contact perpendicular to each other. Yes.
Ma'am, we know
AO
that
is the
AO
bisection
is
of
equal
angle
to
AO.
root A, root
Yeah,
2A.
correct.
And we can take AM as
Angle
A, ma'am. And by that we can use the Pythagoras theorem and find the OM.
Find OM, yeah. How do we use trigonometry, children? Please use trigonometry and find OM. I told you to take this as M. Take this one as M. This point is M. I want you to use trigonometry and find the length of OM. Connect one acute angle. Trigonometric ratio connects an acute angle with two sides in a right triangle. So the right triangle is AOM. So we have the right triangle AOM. Get the value of one acute angle in this. Connect that acute angle with the side which you want to find and one side which is known to you. That's all. Yes, I want one, at least one of you. At least one of you to tell me.
Ma'am, can you repeat the question?
Okay. Why after such a long time? Okay. I'd have repeated it earlier.
Ma'am,
See,
network issue, ma'am.
yeah. So, okay. So, now to find the value of capital R, we understood that we need to find the length of AC. We need to find AC. In fact, AC also can be found using trigonometry. AC also can be found using trigonometry. Okay, so we found AC using a different way. We use the formula root 2a or a Pythagoras theorem. We found AC. Now, to find the length of OM, to find OM, how do we use trigonometry in right triangle AMO to find OM? That's the question. Using trigonometry, how do we find the length of OM? Is my question clear, children?
Yes, ma'am.
Yeah. Okay. So look at the right triangle AOM. Identify an acute angle there. Please find an acute angle.
Angle AOM.
Angle AOM. AOM. How much is it? No, you need no. Identifying acute angle meaning you should know the magnitude of one acute angle. So don't we know that angle MAO is 45? Because the diagonal in a square bisects the angles.
Yes, ma'am.
We have learned this in quadrilaterals, but maybe last year the portions were deleted. Okay, so diagonal AC. Otherwise, also you know the property in a square, the diagonal bisects the corner angles. Diagonal AC bisects angle A and angle C. Diagonal BD bisects angle B and angle D. So this angle is 90 degrees. AC diagonal bisects this angle. So 45. So this angle is 45. Okay, so now step 1, there should be a right triangle. Yeah, we have a right triangle. Step 2, in the right triangle, you must know an acute angle. Okay, I know this angle is 45. Now you have the acute angle. Now connect this with this acute angle. You should connect one. Now since you see in the trigonometric ratio, there should be one unknown and two knowns. Two things should be known to you. One thing should be unknown. That of the three things, one acute angle and two sides. Of these three, one should be unknown. So what is unknown? OM is unknown. OM is what we have to find. OM is unknown. So the remaining two should be known to you. OM is unknown. The remaining two should be known to you. Okay, the angle 45 degrees we know. And we also know that OA is, what did we find? I think root 2A. OA we found is root 2A. Now your work is to connect 45 degrees with OM and OA. So how are the sides related to angle 45? Angle 45. How are these two sides related to angle 45? So for angle 45 degrees, OM is which side? Opposite or adjacent side? For this angle
Opposite
45
side.
degrees. OM is the opposite side. And what about OA? It's the hypotenuse. You cannot say adjacent side because it's a hypotenuse. It's opposite of the right angle. It's a hypotenuse. So you're connecting this 45 degrees angle with the opposite side OM and the hypotenuse OA. So opposite by hypotenuse is sine. Sine 45 is equal to OM by OA. That's how you work it. Sine 45 is equal to OM by OA. So sine 45 is 1 by root 2. 1 by root 2 is equal to OM by OA. OM by OA, which is root 2A. On working this, you will get OM is equal to A units. On working this, you will get OM is equal to A units. You have to connect this angle, acute angle, with the two other sides OM and OA. So since it's opposite side, for the angle, this is the opposite side, opposite and hypotenuse. So sine 45 is equal to OM by OA. Sine 45 is 1 by root 2. 1 by root 2 is equal to OM by OA, which is root 2A. Working that, you will get OM. Now to find the ratio of the circumferences, children, don't find the circumference. Right, find the ratio straight away. 2 pi small r by 2 pi capital R. To find the ratio, don't find the numerical values. Don't find 2 pi small r, 2 pi capital R and waste time. Find the ratio straight away. 2 pi r by 2 pi small r by 2 pi capital R. So 2 pi in the numerator and denominator gets cancelled. So the ratio is nothing but r by r, which means a by root 2a, which is 1 by root 2. Yeah. Don't find 2 pi r separately. Find the ratio. So 2 pi, ratio is 2 pi small r by 2 pi capital R. 2 pi in the numerator and denominator gets cancelled. So small r divided by capital R. Small r is a. Capital R is root 2a. A gets cancelled. 1 by root 2. Again, the ratio of the areas. Don't find the area separately. Find the ratio. Pi small r square. Yeah, pi small r square by pi capital R square. Pi cancels out. R square by R square. R by R the whole square. R by R the whole square. We just found no R by R. What was that R by R? We just found 1 by root 2. So 1 by root 2 the whole square. 1 by 2.
Yes.
1 by 2. The ratios are 1 by root 2 and 1 by 2. I'm saying don't find the circumference or the area value separately. Find the ratio straight away. Write 2 pi r by 2 pi r. 2 pi small r by 2 pi capital R. And then for ratio of areas, pi small r square by pi capital R square. So pi will get cancelled or 2 pi will get cancelled and you get the ratio straight away.
Session completed.
All right. Just a minute, children. Please do the eighth one here. 8. And the other day we discussed the 13th one. I don't think we worked it. Yes, I want you to do the 8th one first. And then.
Ma'am, we did 13th question earlier, ma'am.
No, I think we only discussed how to work the answer. Did we work and get the answer? Okay, if it's over,
Yes.
we'll do some. Okay, we did it. Is it? Okay. I don't remember that. All right. Okay, in that case, we'll do the 14th one. Just make sure, just check and let me know. If we have worked it, then we'll leave that. We'll do the 14th one. I'm sure we didn't do the 14th one. Now we'll start with the 8th one here, children. Do the 8th one.
Ma'am, we did that sum as the 6th question on 21st May.
This one, 13? Okay. 13th, is it?
Yes, ma'am.
Yes, ma'am. Answer is 143.
Oh, thank you so much, children. All right, fine. Then we'll do the 8th one in this paper. 8 and then we'll do 14. We'll do 8 and 14. Yes, what's the value of the perimeter of the figure?
282, ma'am.
How much?
282.
282, but I thought somebody else, I heard something
150,
else.
ma'am.
150, yeah?
Yes, ma'am.
Who says 150?
Tirunesh, ma'am.
Tirunesh, okay. Tirunesh, just see where you've gone wrong. You can see the answer here. You can see the answer here. The perimeter of the figure is OA plus OB plus length of arc ACB. The perimeter of the figure is OA plus OB plus the length of arc ACB. You can see it here. 270 is the major sector angle. It's simple, but why? Tirunesh, I want to help you. Please tell me why you got 150.
Instead of 270, I put 90, ma'am.
Oh my God. Okay. But you had added 42, right? 2 times.
Yes, ma'am.
Okay. So instead of 270, you took 90. Okay.
Excuse me, ma'am.
Yeah,
Excuse
but
me.
yeah, tell me.
Ma'am, doubt me.
Yeah, please ask me. Yes.
This is a major sector only known, so that we can find the only the perimeter of the sector. Why we are adding 84?
Why we are adding?
84, ma'am. I cannot understand the figure.
Okay, okay. Let me tell you. Let me first explain the figure. Okay. Okay, so the first thing is the word perimeter. The word perimeter applies to a closed figure. It talks about the length of the boundary of a closed figure. Perimeter is the length. Perimeter is the length of the boundary of a closed figure. Here the figure is this one, OAC. Supposing you start to walk from here. You go along OA and then along the arc ACB and then along BO and finish it. You come back to the starting point. So this is the length of the perimeter. Sorry, this is the length of the boundary. The figure is this one. How do you go on the outline of the figure? OA, then the length of the arc ACB plus BO. The length of the boundary of a closed figure. So if you find only the length of this arc, it's not perimeter because arc alone is not the boundary of the figure. Arc plus BO plus AO.
Okay, ma'am. I understood.
Yeah, thank you. Good. And Tirinesh, you have a doubt why 270 and why not 90? Do you have a doubt there?
No, ma'am.
Okay. So here you see the answer. Here you see it. OA plus OB plus length of arc ACB, which is 270 by 360 into 2 pi r plus 42 and it's here 282.
Ma'am, area of triangle including the circle or excluding the circle?
No, that's what you will have to understand. Sometimes it is shaded, sometimes it's not shaded. It's given in words like this. Find the area of the triangle outside the circle. Find the area of the triangle outside the circle. So you should understand what you have to find.
Yes, ma'am.
Okay. Yeah. We'll discuss this and wind up the class, children. Can I say something? If you have not started, if you've started and found the radius, continue. If you have not found the radius, please, I want you all to join IA. This is one of we have a few ways of getting the radius. This is one of the few ways. So join IA, IB, IC and find the radius. After that, you need to do something else. I'm not telling you. Do it like this. Join IA. Join IB, join IC. And you understand, children, the I is the in center there. Join IA, IB, IC. Then you need to also do something else. Use this. Use the idea that the area of the whole triangle use the idea that the area of the whole triangle is equal to the sum of the areas of the three small triangles. Use this idea and get the value of the radius. Found the radius?
Yes, ma'am. 2 centimeter.
2 centimeters. Can you read? Can you
Yes.
read your steps? Can you read your steps?
Area of triangle is equal to area of 3 smaller triangles.
Okay.
Area of triangle is equal to half into 6 into 8, ma'am.
Very good. You should find 8. You must find AC using Pythagoras theorem. You can see the right angle marked here. So you should find AC using Pythagoras theorem, which is 8. Okay. So half into 6 into 8 will give us the area of the big triangle. Yes, next.
Area of big triangle is 24 centimeter.
Okay.
Area of 3 smaller triangles half into 6 into R plus half
Yeah.
into 8
Okay.
into R.
Srinivasan, after connecting IA, IB and IC, what else did you join?
ID, IE and IF.
Yeah, ID, IE and IF. Then tell us more about ID, IE and IF. What are they?
They are the heights of each of the triangle.
Heights, huh?
Radius.
Yeah, so ID, IE and IF are the radius of the incircle. And we know that this is the point of contact. That is, the sides of the triangle are tangential to the circle. The sides, the three sides of the triangle, they act as tangents to the circle. They touch the circle at D, E and F respectively. The three sides of the triangle, they touch the circle at D, E and F. So the three sides are... So ID is the radius. ID is the radius at the point of contact. So we know that the radius and the tangent at the point of contact are perpendicular to each other. So 90 degrees. So ID is perpendicular to AB. Similarly, IF will be perpendicular to BC. IE is perpendicular to AC because radius tangent at the point of contact perpendicular to each other. That's how you know it's 90. Otherwise, how will you know? If you just join IF, how do you know it will make 90 degrees? How do you know? You can join ID. You can join ID, you can join IE, but how do we know that they make a right angle? That's by the theorem. E is the point of contact of the tangent. EI is the radius through the point of contact. So EI, the radius EI and the tangent AC will be perpendicular to each other by the theorem. Radius perpendicular to tangent at the point of contact. Okay, Srinivasan, so you have, okay, continue. Area of the triangle AIB is equal to half into 6 into
R.
R. Area of triangle IBC is equal to
Half into BC into R.
half into 10 into R. Okay. Then what about area of triangle AIC?
Half into 8 into R.
Half into 8 into R. So here you will get how much? 3R. Here 5R. Here 4R. So 3R plus 5R plus 4R. So that's what? 12R. 12R is equal to 24. The sum of the three areas of the three triangles, 12R is equal to the whole area, 24. So R is equal to 2. R is equal to 2. So now that you got the radius, area of the triangle minus area of the circle will give us the area of the triangle outside the circle. Yeah, it's here. So AC is, you can see it here. AC is 8 by Pythagoras theorem. Area of the triangle ABC is 24. IAB, IAC, IAB, IBC, half base into height. So then this idea, the sum of the areas of the three triangles is equal to the area of the whole triangle. I hope we understood, children. So like this it is. So the required area is 80 by 7 centimeters square or 11.428. Area of triangle minus area of circle. We have to find the area of the triangle outside the circle. So triangle minus circle. All right, children, that's it for today's session. If you have any questions, please stay back. Else you may leave the meeting. Thank you, children. Please complete the last one. Yeah, thank you, children.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, children. Thank you.
Thank you.
Thank you, children. Good night.
Thank you.
Thank you.